Welcome to my science class. In this class, we'll solve sums from class 10 NCERT textbook. The sum says an electric lamp of 100 ohms, a toaster of 50 ohms, a water filter of 500 ohms are connected in parallel to a 220 volt source. What is the resistance of an electric iron connected to the same source that takes up as much current as all these appliances, and what is the current through it? So here we have got an electric lamp, a toaster and a water filter. This is the electric lamp of 100 ohms. It is the toaster of 50 ohms. This is the water filter of 500 ohms. All these three are connected in parallel. There is one more, that is electric. This is R4 is the electric iron. It's also connected to the same source. You have to find out the resistance of the electric iron, that is R4 value you should find out. It is given that R4, that is the electric iron, takes up current that is equal to the current taken up by all these three appliances. We know that current is not same throughout the circuit. The current flows through R1 is different. The current that flows through R2 is different. R3, they all are. The current flowing through all the resistance is not the same. It is different. Current flowing through R1 is I1, through R2 I2, I3 and I4. But it is said, it is given that the current flowing through R4, that is electric iron, is equal to I1 plus I2 plus I3. So, we will first calculate the current flowing through R1, R2 and R3. Applying Ohm's law, to R1, R2 and R3. By applying the Ohm's law to R1, R2, R3, we will calculate the current I1, I2 and I3. So I1 is equal to, V is constant throughout the circuit, the value of V is same throughout the circuit, by R1, that's equal to 220 by 100. It's equal to 2.2 amps. So the current flowing through R1 is 2.2 amps. The current flowing through R2 is I2, that is V by R2. It's equal to 220 by 50. So that's equal to 4.4 amps. 4.4 amps. Then I3 is the current flowing through R3. I3 is equal to V by R3. So 220 by 500 is equal to 0.44 amps. This is the current flowing through R1, through R2 and R3. Now the current flowing through R4, that is the electric iron, is equal to sum of all these currents. I1 plus I2 plus I3 is equal to I4. Now the current flowing through through the electric iron that is I4. I4 is equal to I1 plus I2 plus I3, because the electric iron takes up the current that all these three together take up. That's equal to 2.2 plus 4.4 plus 0.44. That's equal to 7.04 amps. So we have calculated the current flowing through R4, that is the electric iron. Now we have to calculate the value of R4. Applying Ohm's law to R4. R4 V by I4. So R4 is equal to 220 divided by 7.04. 7.04, that's equal to, so if you remove the point, 22000 by 704, so you will get 31.25 ohms. This is the resistance of the electric iron. Therefore, the resistance of the electric iron is 31.25 ohms. Question says, judge the equivalent resistance when the following are connected in parallel. There are two connections, one is A, B. In A, 1 ohm resistance and 10 to the power of 6 ohm resistance are connected in parallel. In B, there are 3, 1 ohm, 10 to the power of 3 ohms, 10 to the power of 6 ohms, all three connected in parallel. You have to find out you have to judge the equivalent resistance when the resistances are connected in parallel. Then the equivalent resistance equivalent resistance will be less than the smallest individual resistance. Smallest individual resistance. When the resistances are connected in parallel, then the equivalent resistance will be less than the smallest individual resistance. So in the case A, in this question, the equivalent resistance will be less than 1 ohm. The equivalent resistance will be less than 1 ohm. Less than 1 ohm, because the 1 ohm is the smallest one. So it will be less than 1 ohm. In the second case, here also 1 ohm is the smallest one. Same thing. The equivalent resistance will be less than 1 ohm. Please like, share and subscribe. Thank you.